Elements of the database environment. So in Figure 9.3, we're provided with a comprehensive breakdown of the database environment, which is comprised of four fundamental components. These components include the users, the database management system or the DBMS, the database administrator, and the physical database itself. So today in our current discussion, we will delve into a thorough examination of each of these individual elements. So let us now discuss the first element of the database environment, which are the users. So in Figure 90, we can observe the various avenues through which users gain access to the database, and there are two distinct methods. The first method involves user application programs that are crafted by systems professionals. These programs serve to dispatch requests for data access, often referred to as calls, to the Database Management System or DBMS. The DBMS in turn verifies these requests and retrieves the requisite data for further processing. Interestingly, when using the mode of access, the DBMS operates in the background and remains unseen by users. Consequently, the presence of the DBMS becomes almost transparent to them. Furthermore, when considering the procedures for data processing, both in batch and real-time scenarios, such as those involving transactions like sales, cash receipts, and purchases, the operations the operations essentially mirror what would occur within a flat file environment. This continuity in processing procedures holds true despite the adoption of the DBMS framework. Now let us turn our attention to the second method of accessing the database, and this is done through what we call a direct query. Interestingly, this approach doesn't necessitate the creation of formal user programs. Instead, the DBMS itself is equipped with a built-in query facility. This unique feature enables authorized users to work with data without having to rely on professional programmers to assist them. The query facility offers a user-friendly environment that facilitates the integration and retrieval of data, which is then utilized to generate ad hoc management reports. This particular aspect has proven to be a compelling incentive for users to embrace the database approach. In essence, this approach empowers users to independently process data and derive insights, further contributing to the appeal of utilizing a database system. So moving on to the second key element outlined in Figure 93, we arrive at the Database Management System, or DBMS. This essential element furnishes a controlled environment that serves both to facilitate and restrict user interaction with the database while efficiently managing the data resource. Although various DBMS models achieve these objectives through distinct methods, these are certain characteristics features that tend to recur. So first one is the program development. So within the DBMS is application development software. This tool is employed by both programmers and end users alike to fashion applications geared towards database access. Second one is the backup and recovery. In the course of operations, the DBMS periodically generates backup copies of the physical database. In cases of calamities such as disk failures, program errors, or malicious activities that render the database unusable, the DBMS can restore a previous version that is confirmed to be accurate. While minor data loss might occur, the backup and recovery functionality is critical for safeguarding the database against potential total destruction. Third is the database usage reporting. So this feature captures and records statistics related to the usage of data. So it tracks what data is accessed, when it is accessed, and who the users are. So this valuable information aids the database administrator or the DBA in tasks like assigning user permissions and maintaining the database. We will We will deal with it later, deeper into the role of the DBA in this section. So database access for the fourth one. Perhaps it is the most crucial function of the DBMS is to allow authorized users access to the database. So in figure 9.3, it illustrates three distinct software modules that facilitate this task. First one, the data definition language, then the data manipulation language, and the query language. So these modules work in unison to enable efficient user interaction with the database, enabling tasks like defining data structures, modifying data, and querying for specific information. So in this comprehensive manner, the database management system plays a pivotal role in the database approach, providing a, providing a structured framework for data management and user engagement. Now let us turn our attention to the concept of the Data Definition Language or DDL, which serves as a programming language crucial in shaping the physical structure of the database for the Database Management System or DBMS. This language allows us to distinctly define various aspects of the database, such as the identities of individual data, elements, the interconnections between records, and the organization of files that collectively form the database. These definitions occur across three distinct levels, commonly referred to as views. So these three are the internal view, the conceptual view or the schema, and the user view or the subschema. The connections between these views are highlighted in Figure 9.4, which provides us with a visual representation of their interrelationship. Through the application of the DDL, we can meticulously scope the foundational structure of the database, ensuring that it aligns with the specific needs and perspectives of both the internal system and the users. Now let us delve into the details of the different views within the database framework, which you can see here in Figure 9.1. So the first one, which is the internal view, it offers insight into the physical arrangement of records within the database. It represents the lowest level of representation, one step removed from the actual physical database. Here, the internal view outlines the structure of records, their linkages, and the specific physical arrangement and sequence of records in a file. So take note that only one internal view of the database exists. So the next one, the conceptual view or the schema. So on the other hand, it provides a logical and abstract representation of the database rather than reflecting its physical storage. So this view is designed to allow user programs to request data without needing to know how the data is organized or where it is stored physically. Importantly, there is only one conceptual view for any given database. Third, the subschema or the user view. So in contrast, it defines how a particular user perceives the section of the database they are authorized to access. So to that user, their user view essentially constitutes the entire database from their perspective. Unlike the internal and conceptual views, the numerous distinct user views can coexist. For example, an employee in the personal department might see the database as a collection of employee records, unaware of the supply and inventory records visible to those in the inventory control department. So, in understanding these views, let us now take a closer look at how they function within the database management process. So, the DBMS operation it involves several steps that elucidate the roles of these views. So here's a simplified overview of the typical sequence of events, which you can see also sa binigay na copy ni Sir Ariel Serrano. So the first one, a user program initiates a data request or call directed at the DBMS. So this request is formulated in a specialized data manipulation language that's embedded in the user program. So the second one, the DBMS evaluates the request by comparing the called data elements against both the user view and the conceptual view. If the request aligns with these views, it is authorized and the process proceeds to the next step. However, if it doesn't align, then the access will be denied. Third, the DBMS determines the data structure parameters based on the internal view and conveys them to the operating system. Then the operating system engages in the actual data retrieval using these parameters. And these parameters encompass the organization and access method necessary for retrieving the requested data. The fourth one, the operating system employs the appropriate access method to interact with the disk storage and retrieve the data from the physical database. Next one, the fifth, the retrieved data now then the retrieved data then is stored in a designated main memory buffer area managed by the DBMS. Sixth, the DBMS then transfers the data from the buffer area to the user's work location in the main memory. So at this point, the user's program can freely access and manipulate the data. Last one, the seventh, upon completing the processing tasks, the steps involving data retrieval, storage, which are the steps 4, 5, and 6, are reversed. So after the reversal, this restores the processed data to its place in the database. For the next one, let us now go to the concept of data manipulation language or DML, a proprietary programming language that is specific to a given database management system. So the DML serves as the means by which data is retrieved, processed, and stored within the DBMS. This language can be employed in multiple ways. Entire user programs can be written exclusively in the DML, or selected DML commands can be incorporated into program written in widely recognized languages like PL/1, COBOL, or Fortran. This adaptability to integrate DML commands into programs written in universal languages serves a crucial purpose. It allows for a smooth transition of legacy application programs originally designed for flat file environments or earlier types of DBMS into the um, into the present database environment. By simply inserting DML commands into these programs, organizations can effectively convert them to function seamlessly within the current context. Furthermore, this approach brings out a degree of autonomy from the DNS vendor. If an organization decides to switch vendors uh, and opt to and opt for a DBMS that employs a different DML, they won't be obligated to rewrite all of their user programs. Instead, they can replace the old DML commands with the new ones, thus adapting the user programs to operate within the new environment. So, by adopting this approach, organizations can minimize the disruption caused by transitioning between different DBMS, protecting their investment in existing programs, and ensuring a smoother migration to newer technologies. So let us now focus on the query functionality inherent in the database management system, a feature that empowers both end users and professional programmers to directly access data within the database, circumventing the need for conventional programming methods. IBM's in structured query language, or SQL, often pronounced as SQL, has has risen as the standard query language for a spectrum of DBMS, spanning both mainframe and microcomputer platforms. So SQL is categorized as a fourth generation non-procedural language, and it comes equipped with an array of commands that facilitate the straightforward input, retrieval, and modification of data. So one of the standard commands in SQL or SQL is the select command. a potent tool designed specifically for data retrieval. So to illustrate its prowess, consider the example presented in Figure 95, which is in the next slide. So this instance showcases the, the usage of the select command to generate a user report from a database named inventory. So through this command, complex data queries can be executed with ease, rendering data access and manipulation a more user-friendly and efficient process. So turning our attention now to SQL or SQL, we encounter a highly efficient tool for data processing. So despite its departure from natural English language, SQL offers a unique advantage. So it demands notably less training in computer concepts and requires fewer programming skills compared to a range of other languages. So what is truly remarkable is that many database query systems even eliminate the need for for any familiarity with SQL altogether. Instead, users are empowered to interact with data visually, a process as simple as pointing and clicking on desired attributes. So in response, the visual user interface steps in, so taking care of the heavy lifting by automatically generating the required SQL demands or SQL commands rather. So this particular feature is a game changer, placing the power of ad hoc reporting and data processing directly into the hands of users, including managers. By reducing the reliance on professional programmers, this turn grants um, this turn grants managers a heightened capacity to effectively tackle emerging challenges as they arise. With this increased autonomy, they are better equipped to navigate issues and make informed decisions, bolstering their ability to steer their organizations in the right direction. So if we will go back to Figure 90 from the previous slides, we can see the significant role of the database administrator or DBA within this context. It is crucial to note that this position is absent in the flat file environment. Within the database framework, the DBA assumes a pivotal responsibility in overseeing the management of the database resource. As multiple users interact with a shared database, the need arises for a structured approach encompassing organization, coordination, rules, and guidelines. This collective framework plays a key role in protecting the integrity of the database. So in essence, the DBA's role is paramount in maintaining the optimal functionality and coherence of the database, ensuring that it remains a reliable and valuable asset for the organization. Within larger organizations, the role of a database administrator or DBA can expand into an entire department comprising technical experts working under the guidance of the DBA. So in contrast, smaller organizations might have someone within their computer services team take on the responsibility of a DBA. The scope of DBA duties is complicated, so it encompasses several distinct domains such as database planning, database design, database implementation, database operation and maintenance, and the management of database changes and growth. So to provide a more comprehensive overview, Table 9 Watch, which you can see in the next slide, offers a detailed breakdown of specific tasks within these broader domains. This organized um, this organized delineation of responsibilities aids in understanding the diverse functions that fall under the purview of a DBA and underscores the significance of the role in ensuring the effective management and growth of a database. Now let us turn our attention to Figure 96, which you can see in the next slide, where we can observe various organizational connections involving the DBA or the database administrator. An especially noteworthy aspect is the dynamic between the DBA end users and the system professionals within the organization. It is helpful to cross-reference Figure 93 while examining this relationship. So as information needs emerge, users within the organization formally submit requests for computer applications to the system's professional, commonly known as programmers. These requests are managed through established system development procedures, resulting in the creation of program applications. So in Figure 9.3, this relationship is depicted as a line connecting the user block to the system's development process block. However, these user requests also find their way to the DBA, who assumes the role of evaluating them to ascertain the specific database requirements of the user. So, once these needs are identified, the DBA grants authorized user access by configuring the user's view or subschema through programming. So, this relationship is illustrated through lines connecting the user to the DBA and the DBA to the DDL or the data definition language module within the DBMS. By maintaining a separation between access, authorization, and systems development, the organization achieves enhanced control and security for the database. This distinct division makes intentional and unintentional attempts at unauthorized access more likely to be detected as the two groups, which is access authority and application programming, operate independently. This segregation bolsters the organization's ability to safeguard and regulate the database effectively. Another crucial responsibility of the database administrator or DBA revolves around the establishment and ongoing upkeep of the data dictionary. This essential component serves to outline the characteristics of each data element present within the database. Through this resource, all users and programmers are afforded a standardized perspective of the data asset, allowing for seamless collaboration and significantly streamlining the process of analyzing user requirements. So, by providing a comprehensive and uniform portrayal of the data elements, the data dictionary plays a fundamental role in ensuring consistency, accuracy, and clarity in how data is understood and utilized across the organization. This invaluable resource acts as a common reference point, making it easier for various stakeholders to communicate effectively and align their efforts in leveraging the database to its fullest potential. Now let us go to the fourth element depicted in Figure 9.3, which is the physical database. So it is positioned at the lowest level within the database framework. Physical database embodies the tangible manifestation of the data. It is comprised of magnetic spots intricately arranged across magnetic disks. In contrast, other levels of the database, such as the user view, conceptual view, and internal view, operate as abstract interpretations of this physical foundation. So to continue, let us now discuss the physical foundation of the database structure. So at this level, the database takes the form of an assemblage of records and files. In the context of relational databases, they are built upon the index sequential file structure. This distinctive architecture, which you can see in the Figure 9.7 in the next slide, combines an index with sequential file organization. This combination not only facilitates direct access to individual records but also supports the batch processing of entire files. Moreover, by employing multiple indexes, a cross-reference known as an inverted list can be formed, enhancing the flexibility of data access. In Figure 9.7, we can observe the utilization of two indexes. The first index contains employee numbers serving as primary keys that enable the unique identification of records within the file. And the second index arranges the record addresses based on year-to-date earnings. This field, used as a secondary key, allows employee records to be sorted either in ascending or descending order according to their earnings. The secondary key also permits the display of individual records with specific earnings balances. The capacity to generate indexes for each attribute in the file bestows a multifaceted, multifaceted perspective on the data. Consequently, data can be examined and analyzed from a multitude of angles, offering insights and facilitating decision-making processes.